Alright guys, let's get started on this. This is the topic 5 review. When we get back from fall break, we have our test on topic 5, the second class meeting, not the first. The first, we're going to have review and writing assignment time. This is a select all that apply. So remember on this, it could be none of the answers, all of the answers, or anything in between. So let's start. We have EG bisects angle DEF. There's angle DEF. And EG, to know that that bisects, it would have to mean that these are congruent. And since they are congruent, their angles are congruent. Since this cuts the opposite side in half, this in fact does bisect angle DEF. Our second statement is triangle DEF is an isosceles triangle. Well, again, here's DEF. This is an isosceles triangle by those congruency marks. So we've got that as a yes. EG is the perpendicular bisector of DF. Well, we know that it's already that DEF is bisected by EG, and we know that DG and GF are congruent. So through theorem 5.1 and 5.2, 5.3, we would know that that is in fact perpendicular, so we are good there. And then to test this, if we know that this side is 3y plus 4 for this angle, and this angle is 5y minus 10, and we've already said that it does bisect angle DEF, we would just say 3y plus 4 is equal to 5y minus 10. To keep everything positive for my y values, I'm going to go ahead and subtract 3y from both sides, add 10 to both sides. That's going to give me 14 is equal to 2y, and y is equal to 7. And then I can just plug it into either one of these. Not really difficult to do either one, but I'm just going to go ahead and do 5y times 7 minus 10. That's going to give me 35 minus 10. So we have finally hit the one I've been talking about forever, and that is all of these are the right answer. Now that doesn't mean this is test form B. This does not mean your test form will have them all be the right answer. You still have to check all of those. But for your review, they are in fact all true. All right, let's look at number 2. Which of the following statements must be true? That's just another way of saying select all that apply. So it's like this test is going to rely heavily on select all that apply. So you need to be really careful when you're answering these and really examine them before you choose an answer. So first I have side AB, that's this one, is greater than side BC. Well, if BC is 87 and this makes a linear pair, then I would have to know that this side is definitely greater than that side. So if this side is greater than 87, AB would definitely be greater than BC. And if you want to see the math behind it, 180 minus 87, so we can figure out what this unknown angle is, would be, what, 93? If I add 3 there, yeah, I get 90. So yeah, this angle would have to be 93, and 93 would obviously generate a longer side length than 87. If AB being greater than BC is true, then AB will not be less than BC, so that's obviously not going to be an option. BD bisects ABC. Here's ABC. BD is saying that it's bisecting this angle up here. Well, that's not possibly the case because we know that these side lengths are different, and by our Hinge theorem, if this side is less than this side, then these angles cannot be the same. Otherwise, we would have a perpendicular bisector, and then these sides would have to be the same length, making this impossible. And the circumcenter lies on BD. Circumcenter is when we draw a circle on the outside. and then we find the center of it. Now, the clue here should be we never actually talked about the circumcenter in class. We talked about the incenter. Now, I'm not saying that the circumcenter is not a real thing, but I am saying for this test, we haven't talked about it at all. So you won't be expected to find it. Alright. That being said, these next three questions aren't going to be on your test. What is the circumcenter? What is the orthocenter? And what is the centroid? Realistically, I could ask you the centroid. We all did it in class. I even gave you the extra credit assignment on it. So let's say for certain you will not see 3 and 4. No, you're not going to see any of these. We're not going to do that. Alright, so let's go straight on to number 6, which will be at the top. Alright. Triangle AEC, that's the big guy, is shown below. F is the centroid, so we know that it's in the centroid, which is the centroid's found by the concurrency of medians, right? That's where all the medians meet. That means if I were to find the midpoint of AE and mark it, it would pass directly through, and that would be the point of concurrency F. So here, since I don't have numbers, I can't actually measure this and figure out where it would be, but what I do know is, by definition, the centroid's where all the medians meet, so I could just do this, and that's going to find me the midpoint of AE by the definition of the centroid. So now let's actually read the question. F is the intersection of, oh, well, I gave the answer away without actually reading it. That is the medians, right? Now, how do I know it's the medians? Because if I look at each angle and I go to its opposite side, it's cutting the opposite side into congruent parts. And just like I said here, passing through angle C to the opposite side AE, if I pass through where the other two medians meet, I would find that point of concurrency, which is the concurrency of medians. And by definition, the centroid is where the medians meet. All right. Number 7 says, what is AD if FD is 5? So let's do FD here. Now remember the trick I showed you. The short side is half of the long side. So 1/2 times what number equals 5? And that means I would multiply both sides by 2 to find x, right? Because I got to do the opposite. 2 times 1/2 is 1, so I am left with x equals 10. So now I know AF is 10, but let me double check my question. I want to know what is AD. That's the whole line from A all the way to D. 10 plus 5 is 15. If you want to check this, you would ask, what is 1/3 of 15, right? Because that's the whole line. AD is 15 is what we're saying. FD would be 1/3 of that length by definition. So I should get this to be a true statement. And 15 divided by 3 is 5. So this is 5. So we know that we have done that correctly. Suppose BE is 15x squared. Let's try and get all of this on one screen. Perfect. So suppose BE is equal to 15x squared plus 3y. So if I come back up here, BE is the whole thing. That's very funky too. And it says, what is EF? EF is definitely the longer part, so I just need to find 2/3 of this whole thing. So, is that an E down here? Yeah. EF is equal to 2/3 of the whole length, which is 15x squared plus 3y. A hint, especially at this level that you're doing this correctly, is we can see that everything here is going to end up being divisible by 3. So that's going to help us see that we've at least set up, or at least thought about it correctly. Now, of course, a lot of you are probably thinking, yeah, but 1/3 would work as well. But here, as I said, we're going to suspend that rule just for now. That is definitely, BF is definitely shorter than FE. So the length of BF is definitely less than the length of FE. So we know FE has to be 2/3 of the total distance of the line. 2 times 15 gives me 30, divided by 3 is 10x squared. And here, 2 times 3 is 6, divided by 3 is 2y. So I should have an answer 10x squared plus 2y. And then, just so that you can see something here, if I was going the 1/3 route, everything would still work out, but I would end up with the shorter side. So let's look at that. Even though it's not asking it, I want to show you how you know you're doing this correctly or why this works. So what I'm doing here in this purple isn't explicitly asked in the question, but let's say you were doing the test and you went with the short side by accident, or you recognize FB is the long side, but you put 1/3. I'm going to show you a quick trick that would work it all out for you anyways. 15 divided by 3 is 5x squared, and 3 divided by 3 is y. Now, if I take that and I add it together, I should get the full length, right, by the segment addition postulate. This is going to return back 15x squared plus 3y, which is exactly where we started. So we did find the 1/3 and 2/3 sections correctly. We were able to check our work that the math we did do would turn out. But be careful, notice that when I applied the wrong section here, right, when I said BF is what we were looking for, it still came up as a possible answer. Don't fall for that. Make sure you're looking at the longer side. If you're looking at the longer side, you're using 2/3 of the total length. If you're looking at the shorter side, you're using 1/3 of the total length. And if you finish early on the test and you want to double check, go back and find that 1/3 length, and then show that through the segment addition postulate, you can add them back together and get the original given length. And then you know for sure you've done all of your math right. Number 9, if EF is, what is EF if EB equals 3x? So we know that EB needs to be 3x. So that means the whole thing, and this one we can do in our head, is 3x. Well, one of the rules I told you is the shorter side is always 1/2 of the longer side. If I have 3, 1 is 1/2 of 2, and 1 plus 2 is 3. So we're going to end up with 1x plus 2x. This is going to be the shorter side, so this will be BF, and this will be FE. And then we can see through the segment addition postulate that BE would in fact have to be at 3x to get there. So all of that is simply saying I saw that I had 3. The only numbers that add up to 3 that are whole numbers were 1 and 2. And then I saw that 1/3 of the length is 1x, and 2/3 of the length is 3x. And the reason I could do that in my head really quick is 1/3 times 3 just becomes 1, as well as 2/3 times 3 simplifies to be 2. So I know my answer here was it asking for a EB. EB is my long side. So before I even go all the way down again and check, I'm going to say that EB is equal to, oh no, what's EF, right? EF is 2x. So let's close my annotation tool. I see 2x is an option. I've labeled it when I checked it right here as FE, EF, FE are the same line because it's just going from left to right, right to left in the way that I'm imagining this being constructed. So yeah, 2x is your answer. Obviously x would be the 1/3 section, but we're looking for the 2/3 section. Here, this is just 1/3 times x. You didn't need to do your simplification, and here is just 2/3 times x. Again, missing out on your simplification in the process. That would just be a multiplying error. All right, list the sides from shortest to longest. So first we got to make sure we're doing shortest to longest. For some reason, and I don't know why this happens a lot on this test, the stuff that you guys have been doing since elementary school is where you make the mistakes. It's the new stuff that you have no problem with. The first thing I need to do is figure out what is this angle, so I know which is my largest angle, which is my smallest angle, and which one's my median angle or my middle angle. So I'm going to say 54 plus 61 equals 115. 180 minus 115 is going to be 65. So 65 is my largest angle. So the side opposite of 65 is MN. So that's my largest. So let's go shortest. That's S. Middle, long. My longest side is going to be MN. 61 is my second longest. That's going to give me for my middle NO. And for my shortest side, it's going to be opposite of 54. That's going to be MO. So do we have an MO, NO, MN? MO, NO, MN. And that's going to give me option C. All right. Number 11. What is LN? Well, we can see this is a bisected angle, which means if this angle is bisected, its opposite side is bisected. So I can come in here, let's get away from the purple for a little bit, and say these are congruent. So then I can say that m plus 7 is equal to 2m, and I can see very easily that m is equal to 7. And here I'm just going to put 7 plus 7, or I can do 2 times 7, but either way I'm getting 14 from that. All right. Number 12. Which of the following describes MO? It is an angle bisector, right? Because it cuts the angles in half. Is it a median? Well, yeah, if it wasn't a median, we couldn't have proven that or said that m plus 7 is equal to 2m. So far we know those two are right. Let's see. Oh, geez. This is going to be a funny one. Don't, please on the test, don't just assume because this is happening twice on this one review that this is going to happen on your test. All right? And what I'm saying here is if it's a median and a perpendicular bisector, then it's automatically an altitude, right? That's the definition of an altitude, is when I have this and this happening at the same time, I get that. Since this is bisected, an angle bisected, and the sides are bisected, this must be a perpendicular bisector. And because it's both a median and a perpendicular bisector, it's an altitude. So for the second time on one form, we have a select all that apply that end up being a select all that apply across the board. So please be careful with that one on the test. Don't take it for fact that just because the review had it, the test will have it. Which of the following does line segment MO contain select all that apply? Let me check the words. We have circumcenter. We didn't cover that. Or orthocenter. So this will be removed from your test. Here we have another of our Hinge theorems. This year, the class responded really well to this one. And I was really surprised, but I'm still going to go in depth. You can always fast forward if you were still feeling really good about this. First thing I have to do is look at my two angles, because that's where my variable is. So I'm trying to solve for the variable, right? What is the possible ranges for x? Well, I know that 2x minus 4 generates a side length of 48, and 28 degrees generates a side length of 50. Since this side length is longer, I know that 2x minus 4 must be less than 28 degrees for this to make sense. And then here's the part where some of my questions came up. This angle, 2x minus 4, was generated by rotating away from this side length to here. So I have to say the minimum that this would open to have that angle created would be at least greater than 0. So I would also have this. And my goal here is to generate this compound inequality for a possible range of x values. If I solve for this one, I get 2x is less than 32, which means x is less than 16. Here I get 2x is greater than 4, and that means x is greater than 2. So what I'm going to do here now is kind of look at how these inequalities fell out when I simplified them. Here I have x is less than 16, so I have to hold that to be true. This is my portion that says x is less than 16. And here I have x is greater than 2. Well, here I can see x is greater than 2. So my answer would be x is greater than 2, but less than 16 degrees. You can add the degrees if you want. All right. Oh, geez. We've been doing e-learning so long, I almost said any questions. All right. So let's look at this. Let's look at this one. Let me get my stuff set up. Suppose that AH, that's this whole line here. Let me do this. Put AH in blue. Is less than GB. Let's go green for GB. So we know my blue line is shorter than my green line. My green line's longer. What is an inequality that relates ABH? Let's put this one. So from A to B to H is this angle right here, the whole thing. And GH to B. Wee. So if I look at these, let me go back to my original colors. This GHB angle generated my green side length, and my ABH generates my blue side length. And since I know that blue is less than green, I can say the angle that made the blue is less than the angle that made green. So what I can do is come back in here and just rewrite this as blue, which is ABH. And of course, we're talking about the measures of these angles, is less than the measure, of angle GHB. I'm always a big fan of color coordinating everything. I think it makes it easier for all of us to see it. It makes it easier for me to follow. But double check, AH was generated by angle B, and GB was generated by angle H, which is a lazy way of saying that basically if I look at this angle and this angle, which one's greater? Well, H is definitely greater than B. All right. That was number 15. Oh, let me get this. So number 16. All right, we have our first actual word problem here. So let's make sure we take time to fully analyze it and think about what it's asking before we jump in. The frame designer is making a triangular frame. So we know we're going to be building a triangle. She has two side lengths of 18 inches and 27 inches. What are the possible lengths in whole inches? So that means here we're probably going to round. So I'm going to put that in a different color just so it calls my attention to it for the third side. Now, I know I highlighted that and I said it sounds like we're going to have to round, but this is reading like a triangle inequality theorem to me, which is just telling me that A plus B must be greater than C. And to do that, I'm going to take 18 plus 27 and say that must be greater than C. Oh my goodness. If I take that, it's going to be 18. Sorry, I'm bringing out the calculator because I am on full vacation brain mode. That's going to give me 45. And now I see why this is important. This is something we're going to have to add on to. And then, all right, so now I have to look at it as, I know what my largest side can be. What I need to know now is, what is my smallest side? If I'm looking at my smallest side, that means I have to take 27 as a limiting factor, right? Because that's still, what's the smallest number I can add to B? which is 18, to get a length greater than C. So this is now my longest side, and I need to say A, which is 18, plus B must be greater than C, and B must be greater than 9. Now, just from this right here, I'm going to look at what we have. So let me finish this and see if any of these make sense. 9 inches or less, but this is saying B must be greater than 9, so that is a nonsense answer. 45 inches or more. Well, this is saying C is less than 45, so that doesn't work. I would need the or less and or more to swap in these two answer choices to make this make sense. And now I'm left with not possible and between 10 and 44 inches. Your inclination naturally would probably be either recheck your work or just say this is not going to be possible. Because we got 45 and 9. You recheck your work, you're still going to get. Let's write this as a compound inequality. We can't write it as a compound, but we're going to rewrite it so that it makes it a little easier. C is less than 45, and B is greater than 9. I'm just rewriting this one in a more standardized form. Now, I highlighted in orange here in whole inches, right? This is strictly greater than 9. So 9, let's put this as a conditional. If B equals 9, then B is greater than 9. This would probably be one of the easiest possible proofs. This is supposed to be an equals. It kind of looks like a less than. Sorry. If B equals 9, is this true? 9 is not greater than 9. So that doesn't work. Now if I come back here and I say 9.1, 9.1 works, and that's true. However, we're not in whole inches anymore, right? So what is the first value of B where B is greater than 9 in whole inches? Oh, that's 10. 10 is greater than 9, so that's true. And then we have to look at it this way. C is less than 45. If we say if C equals 45, then C is less than 45. What we're really saying here is 45 is less than 45, and that makes absolutely no sense either. So we have to pick the next whole number that'll make this true. If I put 46 in, that's still not true. If I go down to 44, 44 is less than 45. So now our possible widths would have to be anything between 10 and 44. Those are the only whole inch values that will make sense, and therefore C is our answer. So I haven't done any problem like this or a test like this. I think this is similar to since last year when I talked it over with students. I try not to look at these before I make the videos just so that you can hear my authentic, what am I thinking, what are those things that stand out to me, because test taking strategies are just as important as actually understanding these concepts when we're not measuring you in real world examples, but on pen and paper tests or this year electronic testing. So part of what I want to do for you guys is show you exactly what am I thinking as I'm doing these problems, so that if I am assuming something or if I'm reading too much into it, you and I will learn that together. And if I'm not reading enough into it, we'll learn it together, and then we'll reanalyze the problem on why I may have missed something. So that in whole inches I put in a different color because that was my flag to myself that if my answers aren't making sense, especially with that potential gotcha of not possible, I need to go back and really look at what I put there in that orange line and say, my answer's not making sense. Let's think about it from that perspective and then see if it makes sense. If it still doesn't make sense from that perspective, then we can go with not possible. So be careful, read the whole question, learn to identify the really important information that is going to definitely be used or mandatory to solve the problem. That's what I underlined in purple. I have a triangle, 18 inches for one side, 27 for the other. It's asking for the possible lengths of the third side. That is going to be the triangle inequality theorem. And since my answers here, B is greater than 9, didn't make sense for A because it's not less than. and B is less than 45, or C is less than 45, doesn't make sense because it's not more than. I was left with those last two options. Not possible, again, is really what I was thinking about picking right away. But I had this underlined in orange, so I double checked before I moved forward. I hope you guys start picking up to do the same thing. All right, which point of concurrency always lies on the interior of a triangle? So I told you when we did talk briefly about the orthocenter that this can be outside. And since that's really the only thing, and I kind of showed you a quick example of one, I'm going to leave this question in because, well, we did talk that much about it. I will say safely that, again, we didn't go into circumcenter at all, so I wouldn't choose that one. But let me show you an example of why this one wouldn't work. Let's say I have a triangle like this. And of course, this is highly, highly, highly exaggerated. If I were to draw a circle around this somehow, oh man, that might actually be one of my better ones. And then I take the diameter twice in two different ways. Looks like we're going to be really close. But here you can see that the circumcenter, the circle outside of it, is outside of the circle. Some of our more critically minded students are going to say, well, you didn't exactly hit it there, Mr. Fimble, so I wouldn't make that statement just yet. As the better I get with the drawing tool, the more likely I'll be able to convince you. But this is close enough. Even if I were to bring this in and this in, my diameter would drift, and at most a very small amount. And it's going to be close, but it's not going to be inside of that triangle. So the circumcenter will not always lie in the interior, but we do know the Incenter and the centroid will, right? Centroid is made by the concurrency of medians, and there's no way to draw that where it won't start at a vertex and touch the opposite side of the triangle where it's not inside the triangle. So our centroid is definitely going to be the correct answer. And our incenter, if I have any triangle that I draw a circle around, since it only touches at the points, it would definitely at the center of that circle have to be somewhere inside that triangle, no matter how crazy or exaggerated I draw the triangle. So here we would have incenter and centroid. Circumcenter is not going to be an answer on this. So now you're down to a 33% chance of getting it right instead of a 25% chance. If you're watching this, I'm going to say it in class on Monday and Tuesday. Do not pick circumcenter for anything. I didn't show it to you for a reason. And that's because we don't need it, and it's such an abbreviated year. This isn't going to come up in the future. The orthocenter, we're going to talk about one more time, and the way we're going to talk about it's going to be much easier to do the orthocenter then, so we're shifting that. All right, and 18 and 19. Triangle RST is shown below, and XU. So let's go ahead and start labeling this before we get too far into it. We'll keep the red. XU is negative 4y plus 20, and XW is 6y plus 10. So this is not what we did earlier with the centroid. This is not the concurrency of medians, but this is the incenter. The incenter, if you remember, the way you can identify that is all of your lines that start at the center and head towards the vertex will not match up in a straight line, right? We have not 180 degrees here. This perpendicular line comes up here and then it tilts off to the right a little bit to get to its vertex. Same here, but this one tilts off to the left. This one looks like a straight line, so that wouldn't be the one I'd rely on to know that this is the incenter. Now remember, the incenter is generated where all these perpendicular ones, this might be a little bit better. So remember, each of these that touches the circle and the triangle at the same point, that point of concurrency, and from the center of the circle to the edge of the triangle is 90 degrees. That's how you find your incenter. So remember, that we talked in depth about what a radius is, what the word radii just means multiple radius. And now we know that all radii in a circle are congruent. So I can say xu is congruent to xw and the reason we're saying this is by the incenter. So again, this is a circle, and from the circle we find the center of the circle, and then we draw a line from the center to the opposite side so that it hits at 90 degrees. And it would touch in a more accurately drawn, this is probably the best one right here. The circle and the triangle are concurrent there and only there. There's nowhere else that they touch. This isn't the best example of a tangent line, but very soon we're going to be talking about what tangent lines are. And that is they touch at one point and only one point. They get really, really close to everywhere else, touch, and then they turn in another direction to never touch that line again. So here, if xu and xw are equal, I can just set these equal to each other. Negative 4y plus 20 is equal to 6y plus 10. Here, I'm going to add 4 to both sides. I'm going to get 10y. And here, I'm going to subtract 10. So I'm going to get this. So I'm going to get y equals 1. And then I can plug this into either one of these. All right. Point x represents which point of concurrency? Well, like I said just a few seconds ago, that's the incenter. And we know it's the incenter because all the lines coming out from x are either the radii, which is xu, xv, xw, or looking at it, they're not perfectly straight. Now vt passes through x, and it is pretty straight by my view. But xw, well, let's do it this way. Wx to xr is definitely not 180 degrees, right? It slides to the right. And that is my number one clue that I am looking at the incenter here. Let's move on to our last question. It says a police officer is parked in a supermarket parking lot located at the junction of 2 streets. He wants to be equidistant from both streets. Should he be on a perpendicular bisector, median, angle bisector, or altitude? I'm going to set this one up, and then I'm going to leave this up to you guys to decide. It's parked in a supermarket parking lot located at the junction of 2 streets. So I'm just going to draw this like this. He would be somewhere around here. He wants to be the same distance from both streets. Where should he be? Well, it's on the I don't want to go too much further in this. This is just gonna lay this one out, and I know this one's on one of the test forms exactly as it's written. What I would say is look at your options, and which one of these would always keep him on a line that is the same distance no matter where I go from. If he's anywhere in this parking lot and he wants to get, so the parking lot is this purple area, and these are the 2 streets creating the junction. Of course, this is again, I'll say it, I think I've said it so many times in all of my videos. Since we're in geometry, we have a lot of freedom to draw and interpret it as we see it, because it's going to hold true no matter what. So from here, I just want to know what line would I be on, and I'm drawing this so that when you're reviewing your notes and going over what we did in class, you'll see something that looks very similar to this. I'm not drawing one last clue, but I would encourage you to go back through your notes on this one. And I will tell you that the other form that this one doesn't appear on has a similar problem, but a different answer, and it's about an ice cream vendor at an amusement park. I do remember that from last year.